Look at our world. Earth is a magnificent cradle, but it is ultimately a finite surface. Exponential population growth is rapidly colliding with the hard limits of our planet's available land and resources. We are forced to engineer extreme solutions just to sustain ourselves on a two-dimensional plane. We build higher, dig deeper, and optimize every square inch of a surface we cannot expand. Extracting resources requires digging dangerously deep into the Earth's crust. It is a highly inefficient, energy-intensive process that damages the very biosphere we rely on to survive. The greatest barrier to expansion is the planetary gravity well. Escaping Earth's massive gravitational pull requires catastrophic amounts of chemical energy just to move a fraction of a payload into orbit. Rockets must be manufactured with extreme precision, acting as the brute force battering rams we use to punch through the atmosphere. Yet, traditional rockets are incredibly inefficient vehicles for mass planetary migration. We are essentially a two-dimensional species trapped on a curved plane. To scale our civilization to a population of trillions, we must shift our paradigm and begin utilizing the true three-dimensional volume of space.
Look at the resonance cascade.
The future of humanity isn't moving to another planet like Mars. Instead, the ultimate solution is building our own planets from scratch, customized to our exact biological requirements. Enter the O'Neill cylinder, a megastructure consisting of two massive counter-rotating cylinders. This opposing rotation is a strict engineering requirement to cancel out dangerous gyroscopic torque and maintain stable orbital alignment. In the weightlessness of space, we must manufacture our own gravity. By rotating the cylinder, we use centripetal acceleration to push objects against the inner hull, perfectly simulating a 1G environment. The rotation speed must be calculated flawlessly. If it spins too fast, the Coriolis effect will induce severe motion sickness. Too slow, and the artificial gravity will be too weak to maintain human bone density. How do you contain an entire atmosphere in the vacuum of space? The habitat must act as a monumental pressure vessel, requiring millions of miles of ultra-high tensile cables forged from advanced alloys. To prevent the immense internal air pressure from bursting the cylinder like a balloon, these megastructures will rely on advanced materials like carbon nanotubes, seamlessly woven to provide unparalleled structural integrity. Deep space is deadly, filled with lethal cosmic rays and solar radiation. The outer hull must be armored with dense material, utilizing meters of tightly compacted asteroid slag to protect the fragile ecosystem inside. Alternatively, large baffles of purified water can be utilized within the hull. Water is an exceptionally effective radiation absorber, and distributing it along the outer shell serves a vital dual purpose. To provide light and heat, colossal exterior mirrors must be constructed. These mirrors will unfold outside the habitat, angling to reflect pure life-giving sunlight through massive transparent windows set into the cylinder structure. These colossal window strips must be forged from ultra-thick, tempered silicates capable of holding back the vacuum of space while allowing carefully regulated sunlight to pour into the internal landscape. By mechanically adjusting these external mirrors and internal louvers, the habitat has total control over its climate, effortlessly simulating perfect, programmed day and night cycles for the ecosystem within. An entire Earth-like atmosphere must be synthesized from scratch. Nitrogen, oxygen, and trace gases are harvested, refined, and blended in massive quantities to fill the vast interior volume of the megastructure. To support life, a massive foundation of artificial topsoil must be manufactured. Processed asteroid rock is heavily enriched with organic compounds and synthetic fertilizers to create a nutrient-rich bedrock for the habitat's biosphere. Launching the finished materials from Earth is mathematically impossible. Instead, we only launch the seeds. We pack specialized, automated mining and manufacturing drones into rockets, preparing to send the factory itself into space. To begin constructing our new world, massive heavy-lift rockets pierce the atmosphere, carrying not steel or glass, but the robotic seeds of our orbital industrial complex into the silent vacuum of space. We target near-Earth objects or metallic giants in the asteroid belt. A single medium-sized metallic asteroid contains more iron, nickel, and precious metals than humanity has ever mined in its entire history. Instead of fighting gravity to haul materials from Earth, we capture the materials already floating in space. Autonomous drones fire high-tensile magnetic harpoons deep into the dense, iron-rich crust of the asteroid. Massive, automated ion thrusters are bolted directly to the asteroid's surface. Working in perfect synchronization, these robotic engines will slowly but relentlessly alter the massive rock's trajectory over several months. We gently steer these celestial mountains into stable, high Earth orbits. Here, safely away from our atmosphere, they become the raw, unrefined quarries that will feed our orbital construction yards. Once the asteroid is secured, the payload unfolds. This is the seed factory. It is a fully autonomous, self-contained industrial refinery designed to operate flawlessly in the harsh zero-gravity environment. In zero gravity, traditional mining fails. Instead, enclosed robotic excavators lock onto the surface, using powerful lasers and diamond-tipped grinding heads to chew through the raw metallic ore without floating away. The excavated rock is propelled through a series of electromagnetic sorting rings. Iron and heavy metals are magnetically pulled onto separate processing tracks, while silicates and ice are diverted for later use. We don't need fossil fuels to melt the ore. Massive parabolic mirrors unfold, concentrating raw, unfiltered sunlight to generate thousands of degrees of heat, smelting the metal into glowing liquid spheres. The molten metal is pumped into spinning centrifugal chambers. By using artificial gravity generated by rotation, we cleanly separate heavy elements from lighter impurities, creating perfectly pure aerospace-grade alloys. This is the von Neumann architecture in action, the machine that builds the machine. The seed factory uses the pure asteroid metal to 3D print identical gears, chassis, and robotic appendages. Swarms of automated drones immediately assemble these newly forged parts. Within weeks, the original seed factory has built an exact duplicate of itself, doubling the mining and manufacturing capacity. This triggers exponential growth. 2 factories become 4, 4 become 8. Soon, the entire surface of the captured asteroid is a highly synchronized, sprawling automated industrial complex working in perfect rhythm. To power this massive escalation, the factories use the mined silicates to print miles-long ribbons of solar arrays. These massive energy nets unspool into the void, capturing gigawatts of stellar energy. Once sufficient infrastructure exists, production shifts from replication to megastructure assembly. Colossal orbital forges begin extruding the primary structural ribs of the O'Neill cylinder, kilometers long and impossibly strong. Because there is no gravity to fight, construction requires no cranes. Swarms of agile drones zip through the vacuum, weaving millions of miles of carbon nanotube cables to form the pressure vessel skin. Massive titanium hull plates, pressed from the asteroid's core, are maneuvered into place by tug drones. Automated spider welders crawl over the seams, fusing the plates together in a flawless, airtight metallic shell. The central hub, the heart of the structure, is assembled. Giant robotic arms lock the massive magnetic levitation bearings into place, creating the frictionless anchor point for the two counter-rotating habitats. The crushed leftover asteroid rock isn't wasted. It is systematically pumped into the hollow cavities between the double-layered titanium hull, packing tightly to form an impenetrable shield against deadly cosmic radiation. Piece by piece, an object the size of a city is forged in the silent void. The skeleton of Earth 2.0 is complete, a pristine, empty pressure vessel waiting to be filled with air, water, and life. With the skeleton complete, the great engines ignite. The cylinder begins its precisely calculated rotation. Slowly, centripetal acceleration builds against the inner hull, firmly pulling objects outward and successfully simulating Earth's gravity. Next, we breathe life into the void. Millions of tons of synthesized nitrogen, oxygen, and trace gases are pumped rapidly into the megastructure, pressurizing the interior and creating a stable, perfectly breathable atmosphere. A barren metal floor cannot sustain an ecosystem. Fleets of automated grading machines deposit millions of tons of highly enriched synthetic topsoil, forming a deep, nutrient-dense foundation across the entire curving landscape. Water is the lifeblood of the habitat. Precisely engineered lakes and rivers are flooded with purified water, driven by the cylinder's rotation to flow naturally, creating a dynamic, continuously circulating aquatic network. To build the biosphere, swarms of agricultural drones execute rapid, automated hydroseeding. They blanket the new soil with fast-growing mosses, genetically optimized grasses, and tree saplings, accelerating thousands of years of ecological evolution. In the freezing vacuum outside, the final component is activated. The colossal exterior mirrors slowly unfold on massive hinges, angling their perfectly polished surfaces to capture and redirect the raw power of the sun. Through the massive silica windows, first light finally breaches the interior. The habitat is bathed in warm, regulated sunlight, permanently banishing the dark and initiating the crucial process of photosynthesis across the biosphere. Weather is no longer unpredictable. By regulating humidity and temperature via central mist generators at the cylinder's axis, we have absolute control over the climate, programming rain and cloud cover with mathematical precision. Because gravity relies on rotation, it weakens as you move toward the center. Massive elevator hubs transport citizens from the Earth like 1G's surface up to the zero-gravity axis, offering varying environments instantly. Cities are designed from scratch as integrated arcologies. Automated 3D printers and robotic swarms construct beautiful, highly efficient urban centers that curve elegantly upward, perfectly balanced with the surrounding engineered nature. Transportation is frictionless and instantaneous. High-speed magnetic levitation networks run the entire circumference of the habitat, allowing millions of citizens to commute anywhere in the cylinder within mere minutes. Agriculture does not compete for space with human living areas. Dedicated, interconnected farm rings operate with intense, 24/7 sunlight, utilizing hyper-efficient robotic harvesting to produce massive, predictable crop yields. By utilizing enclosed hydroponic zones with elevated carbon dioxide levels and optimized nutrient flows, we can push plant biology to its absolute limits, eliminating starvation and ensuring total food security. At the very center of the habitat lies the zero-gravity axis. This region becomes a playground for completely new forms of three-dimensional recreation, where citizens engage in weightless sports and human-powered flight. In an environment with normal air pressure but zero gravity, human muscles are finally strong enough to achieve true flight. Strap on a pair of lightweight wings, and the sky's completely yours. Precipitation is localized and programmed on demand. You can schedule rain for agricultural sectors at night, while keeping residential city centers perfectly dry and sunny, optimizing the environment for maximum comfort. As the scheduled day ends, immense exterior louvers smoothly slide shut over the window strips. The habitat experiences a flawless mechanical sunset, triggering the city lights to illuminate the curving night sky.
Interior lighting transitioning to night cycle.
To survive indefinitely, the megastructure must operate as a perfect closed-loop ecology. Every drop of water and every ounce of waste is captured, biologically scrubbed, and completely recycled back into the system. Colossal atmospheric scrubbers built into the end caps ensure the air remains eternally fresh. They constantly circulate the massive internal volume, filtering out impurities and preventing stale air pockets in the artificial atmosphere. This is Earth 2.0, a bespoke, perfectly engineered paradise where nature and advanced industrial efficiency exist in absolute harmony. We have successfully replicated the best of our home planet, removing all its flaws. But the true power of this engineering lies in its scalability. If we can capture one asteroid and automatically build one orbital habitat, the self-replicating robotic systems can effortlessly build millions. The original industrial nodes do not shut down. They evolve into massive logistics hubs, flawlessly coordinating the automated production and continuous launch of thousands of new seed factories deeper into the solar system. We cast our net into the main asteroid belt. An incredibly coordinated swarm of autonomous drones systematically harvests the celestial debris, feeding an ever-expanding, highly efficient network of orbital forges. Habitats network together, allowing for hyper-specialization. Entire cylinders dedicated solely to deep space agriculture can perfectly supply adjacent, densely populated residential arcologies through a highly efficient, frictionless orbital supply chain. This is the foundation of a Dyson Swarm. Millions of independent habitats orbit the sun in a perfectly choreographed mechanical dance, efficiently capturing virtually all of our star's radiant energy output. With limitless energy and materials harvested directly from the void, humanity enters a true post-scarcity era. Resources flow continuously through automated supply chains, completely eliminating planetary poverty and industrial starvation. By breaking free of the two-dimensional planetary trap, the human population capacity scales gracefully into the trillions. We foster countless diverse cultures across thousands of bespoke, carefully engineered biological paradises. Earth is no longer an overexploited factory. It becomes a sacred nature preserve. Humanity finally relieves the crushing industrial pressure on our homeworld, returning it entirely to its pristine pre-industrial biological glory. When the sun eventually crowds, these megastructures will become generation ships. Fitted with immense antimatter propulsion engines, they will carry our artificial worlds flawlessly across the dark, endless ocean of interstellar space. Planets are just the nurseries of intelligent life. Building Earth 2.0 represents our graduation from the cradle. Would you choose to live on Earth, Mars, or an O'Neill cylinder? Let me know below.